Welcome, everyone. My name is Steve Pollock. I'm the Director of Marketing and Design Services at Banyan Hills Technologies. Thank you very much for joining us today. We're very proud to be hosting this demonstration on introducing automation into your IoT workflow. I want to introduce my fellow presenters here today from OptConnect. First, we have Sean Horan. Sean, go ahead and introduce yourself to everyone.
Thanks, Steve. My name is Sean Horan. I'm the Director of Sales for the embedded product line, our ema, Smart Embedded Modem, and look forward to having a great discussion today.
Wonderful. Thanks so much, Sean. And then we also have Matt Voigt with us. Matt, feel free to go ahead and introduce yourself.
Thanks, Steve. Hey, everybody. Matt Voigt here with OptConnect, Embedded Cellular Engineer. Looking forward to showing you some hardware demonstrations today. Go ahead, Steve.
Wonderful. Thanks so much. Just as the title suggests, we plan on demonstrating for you how to use IoT software to automate certain tasks when certain conditions are met. Now, we here at Banyan Hills Technologies, we do the software. We're very, very passionate about software. We love software, but we only do software. So that's why today we brought in our friends from OptConnect. They are passionate about hardware, and they're going to tell you all about the emaPlay, a device that enables cellular connectivity. Sean, would you like to go ahead and tell everyone just a little bit more about OptConnect?
Yeah, Steve, thanks. I'd appreciate that. So OddConnect has been in business for over 10 years. We started out specifically to manage a cellular connection. And we started out in the ATM space where we were connecting remote ATMs. And then we moved more to additional verticals, digital signage and kiosks. And think of us as a white glove managed service. It's not just connectivity. It's the hardware, the software, the connectivity, and all of the monitoring and management on the back end. Some of our customers, really have come to us because of IoT headaches. And either they've tried and they failed to have in their IoT project. They also don't have they want to outsource the expertise of engineering on the hardware side, as well as management of the connections that they have in their field and the fleet. And so once they start, they become overwhelmed and they just need somebody to take that off their plate, and we'd be happy to do that. And obviously, we manage the cellular connection. Cellular networks are great, but they do go down. And we can be first point of contact to fix it. In the case of today's discussion, we're going to be talking about OptConnect ema, which is a smart embedded modem. And it's similar to a socket modem, but it has specific smarts and intelligence that, as well as the managed service on the back end. So additional cost savings for embedded solutions, quick to market, reducing the downtime with the management, and that's the value proposition of OptConnect. And here are the services that some of the services that we offer, and we'll go into more detail on the ema value proposition and what it does. But we talked about the 24/7, 365 management of the cellular connection, ensuring uptime. We provide one-stop shop. If you have a problem with your connection, they pick up the phone, and a customer can pick up the phone, and we are there to triage and support the solution. We are continually monitoring that connection to ensure uptime. A lot of our customers are mission-critical applications that if the machine is down and the network is down, they're not processing transactions, and that can lead to lost revenue or increased costs. We also do a lot of intelligence of managing that connection on the ema itself, and that's the patent-pending pieces of ema that really helps with deploying an embedded solution quickly and easily. So now that we've had a brief overview of Banyan Hills and OptConnect, we would like to do a deeper dive into OptConnect ema and the dev kit that's available called emaPlay. And Matt Voigt is able to take that away. So Matt, go on ahead.
All right. Thanks, Sean. So this slide, what I'd like to do on this slide is go through in detail, and I'll kind of try and point these out on the actual hardware sitting at my desk over here as I go through this. And so what we can see here on the slide is this development kit is very feature packed, and it was designed to be as robust as possible to allow users and host systems that are intending to integrate with EMA as many features and as many integration and deployment options as possible. And so starting over here for power, it accepts a wide input voltage range, 4.5 volts to 30 volts to be specific. You can power it using the barrel connector, which is how I've powered the device down here. Or you can power it using the wire to board screw terminal. And so those, and what's nice about that is if you don't have a barrel connector or an AC power outlet available, you can use the host system's power if it has it available and run the wires over to the screw terminal. And so moving down here, there's an onboard microcontroller. That guy's right over here. This is a 32-bit Atmel Cortex M4F microcontroller. It allows you to write your own applications, which is what we've done in this instance. It's running our demonstration project. You can see the LED signal array down here is lit up with 2 LEDs. It might be a little tricky to see. And so it's indicating OK signal. And in the picture, the LED signal array is right here. There's an onboard J-Link, Seger J-Link programmer debugger built in. And that's powerful because there's no requirement for an external debugger to debug a single-step debug or program this microcontroller with. It's all included in the kit. We've got all EMA interfaces exposed, so this serial to USB port exposes both the module AT UART interface and the EMA Link management interface. And if you see in my hardware over here, I'm actually connected to that right there. And what I'm doing on another screen is I'm monitoring the debug output, hoping everything goes well during this demonstration. And so if we work our way around over here, we've got onboard sensors. So there's a temperature and humidity sensor right there. There's a light sensor right there. There's an input-output application header that you can use to connect other sensors of varying degrees. I2C sensors, UART sensors, analog sensors, almost anything that you can think of can be connected through these headers. There's a power header that you can steal power from if you need to power something else that you're running in conjunction with this kit. And if you look at the actual hardware here, we've got a buzzer that's connected through this power and I/O application header that we're going to be demonstrating and later on as part of this demonstration. And so what you also see here, you also see dip switches. There's 2 sets of dip switches here. There's also a switch on the side. And what this allows you to do is it allows you to direct where EMA's interfaces will go. Will they go here so that you can interact with a computer? Will they go to the wire-to-board terminal or the wire board-to-board terminal so that you can interact with the machine? Will they go to the I/O application header so that you can connect your own microcontroller dev kit? And that's what these switches control. And that's all documented in the emaPlay user guide. And so this particular setup is set up in the mode where we're directing EMA signals to the microcontroller because it's running the IoT application and it's interacting with the Banyan Hills Canopy dashboard. What's also available on this blue terminal is RS-232 and RS-485. And that's very powerful in the machine world, and you can connect things like Modbus, BACnet, PLCs if you want those to connect through cellular using a smart embedded modem like EMA. We also have your standard U.FL to SMA connectors over here. And like we mentioned before, sample projects and app notes are readily available. And then the Banyan Hills Leaf Agent is built into this.
And I wanted to let you know, Matt, and folks that are listening in, you can download the hardware, how to get started, the hardware guide, the software guide, app notes, data sheets. You can go to optconnect.com/Emma. And that's a good place to start on at least what and how to use the Emma.
Yeah, it's a great point, Sean. Thanks for that. You can also reach out directly to anyone in this video. All right, so we've talked about the hardware. So I'm going to go back to the slide here so we can see more clearly. As mentioned, the kit ships with a demonstration project. And really the purpose of that is to provide a full round-trip, soup to nuts IoT application that is highly configurable using the Banyan Hills Canopy dashboard. You can use their IoT campaigns, which are similar to if this, then that type operations to do things pertinent to your business. And like I mentioned before, we're going to demonstrate a couple simple things that you could do with this dev kit out of the box. Let me just quickly go through some of the things that the demonstration software project includes. So it includes, how to start up Emma, initialize it, recover it, and shut it down. Simple, basic stuff, but it's stuff that you need to do correctly, especially the shutdown and the graceful disconnection from the cellular carrier's network. It includes demonstration on how to handle a microcontroller FOTA. There are instances where we will release new features, and if your host wants to take advantage of those, then your host's firmware is going to need to be able to handle the microcontroller FOTA. Board Notify is demonstrated in this sample project, as well as Glimpse and Board ID, features that we talked about a few slides back. It's polling and monitoring the temperature, the humidity, the light, and the various voltages around the board, and you'll see those in real time shown in the Canopy dashboard in just a few minutes. There are 4 user digital outputs that can be controlled again from the IoT campaigns from Banyan Hills Canopy dashboard. You have 2 digital outputs that were made available over here at the I/O header that we talked about. And then you have 2 LEDs that are actually just kitty corner from the signal array, basically right here. And we will demonstrate with those again in a few minutes. There's 3 user inputs, and you can do things like hook up an analog sensor or 1 or 2 digital sensors that you can act upon using the IoT campaigns. It includes the Banyan Hills Leaf Agent, and with that you get device to cloud communications and cloud back down to the device. So full round trip. It demonstrates how to use HTTPS, a secure method of HTTP, and the post REST operation. And then the messages are sent in a JSON format. And so that's a very popular format that's used in the Internet of Things world. And there's a couple screenshots over here. Before, when I showed you that this was connected to a debug input-output or a shell terminal program, this is kind of what that would look like. I know it's hard to see, but basically you can gain various information about the sensors. You can see in real time the operations that are going on relative to the demonstration project. Things like how it maintains its connection, how it handles microfota, how it's building the leaf messages and sending them up. And here's just a snapshot, again, of the input types that you can act upon and the outputs that can be triggered through the IoT campaigns. And now I'd like to hand it back to Steve, who's going to discuss in more detail how the Banyan Hills Canopy dashboard can be used to facilitate automation tasks. Go ahead, Steve.
Thank you very much, Matt. I really appreciate that. When you first log into Canopy, this is the screen that you'll see. We call this the operations dashboard. You can see all of the modules located across the top here, the operations, locations, devices, customers, transactions, inventory, IoT campaigns, marketing, instance, reporting. Not all customers will see all of these. It depends upon the package of Canopy that you have. Moving a little bit further down here, you see the summary KPIs, which are located here. These are all roll-ups of the KPIs located down here further on the table from the individual devices. Here is one EMMA device, and this is a second EMMA device. And so when I said the summary, it would be, for instance, the summary of these two temperature KPIs located right here. Now this, obviously, this temperature is tied to the temperature gauge on this emaPlay device that Matt had demonstrated. So if you wanted to see more information about the history of the temperature on this particular device, click on here and it pulls in the temperature. It shows you the actual temperature at this moment. If there was a history located associated with this particular device, it would show up here. And you could see the other information about the other KPIs as well, the humidity, the light sensor, all these kinds of things are all in there. A little bit more about the device itself. If you wanted to click in to find out more information about the device, you would click into here. You would be able to see more info, more data on the device itself. And then I wanted to just quickly show you this one piece. This is particularly helpful for people who are perhaps trying to troubleshoot or discover what information is coming from the device up to Canopy. This is where we have the actual raw event files, event listings. The data coming from the device itself is coming here into Canopy, in here where we have events listed here. So you can see each event type, statistic, play, the time, the process time, and then the actual JSON code that's coming in from the device itself. You can also, of course, export this to Excel if that's more helpful. You can export it and then slice it and dice it. It's a CSV file, and then play around with the data that way. Now, of course, we're all here today to talk about automation. We provide automation through these IoT campaigns, which are right up here. Now, I'm going to walk you through just a very, very simple one that we have set up beforehand. This just a test campaign that's saved. But just to kind of show you how the functionality works, I'm going to show you here. This is a board here, where you have this drag and drop functionality to be able to build your campaigns and your automation. And just to kind of show you as an example, we have already thrown in here this KPI status. This is a variable, if you will, that you can put in here. So this is a OptConnect network status. If the status is red, which it could be red, green, or yellow, you have this status here. It's a variable, like I said. Now, let's say if you wanted something to happen when that status turns red, I would, for instance, come here and say, okay, I would like an email to be sent to me when the status turns red. I'm going to drag this email over here onto my board. Email opens up here. And if I want to send this email to myself, put in my email address, banyanhills.com. Let's say status is red in the, status is red in the subject line. And then say KPI status is red in OptConnect. Okay, and then, I should have saved that. All things open here, so that's why. Okay, now I'll save it. And so now this stuff all fills in here. And then all I need to do is to connect these up like so. And then whenever I'm ready, I just hit start the campaign. And then what will happen is that whenever this KPI status turns to this particular status, red, it will send me an email saying that the status is red. That's just probably as simple a campaign as you can think of. But it kind of gives you the bare bones of what is the backbone, if you will, for how this all works. To get things just to step it up just up to another level, I'm going to pass it back to Matt Voigt to show you all how we can interact further with the emaPlay device.
All right, thanks, Steve. And so what we've got shown on the screen here is the Canopy dashboard for OptConnect. And what you can see is the two EMA devices that Steve mentioned before. The one that we're going to be focused on, which is the one that you see in the bottom right of the screen, is this guy that ends in 000B. And so in real time right now, it's feeding up the temperature, the humidity, the light, the system voltage, the EMA voltage, and right over there, the signal quality. And so what I'd like to do is I'd like to take a deeper dive into a couple of the IoT campaigns that we've pre-created just for the sake of saving time. So we'll click over here, and what we can see here is the list of the IoT campaigns, and there's basically three that we're going to practice with here. One named Intruder, demonstrating a security system application where it's dark in environment. There's a light sensor on the emaPlay that will detect either the robber shining a flashlight around, or if he's really not too bright, he would turn the light on and it will detect that. And so what's going to happen is it's going to turn the buzzer on that you can see attached to the emaPlay over here, and it's going to latch that buzzer on until we disarm the system using this little button that's hard to see, but I'll blow it up here in a minute, and that's going to turn the buzzer off. And then the last demo we're going to do is we're going to do one where we heat up the temperature sensor with a nifty little heat gun that I have next to me here, and that's basically again going to simulate an alarm, but instead of the buzzer we're going to use another output that's pre-programmed, which is just an LED, and that LED is right down here. And so just as a quick overview of these IoT campaigns, click into the intruder light detected, and what this is doing, it's using the pre-programmed modules that are part of the IoT campaign logic. We're reading an emaPlay sensor, we're loading the data, we're setting a variable local called light value, and then we're going to make a decision on it. If it's less than 2000, it's not going to do anything. The IoT campaign is just going to stop, and that's the state that it's usually always in. For example, when the room is dark. When the light value goes greater than or equal to 2000, and 2000 is just an arbitrary number, it's actually an ADC value that the emaPlay kit is computing and then sending up to the dashboard here. When it's greater than 2000, we're going to turn digital output 1 to a duty of 1 and a period of 1, which just means it's on. And again, after that, it will stop. Or it will only fire the output of the campaign once. And so what we're going to do is we're going to activate this campaign by clicking up there. So now it's active. Go back to our list here. We can see that it's active, and then we can see the disarm system one is also active. And so let's go back to the operations so that we can see the light value in real time as we pretend to be the robber here. So I'm going to blow this up a little bit. We can see that the light value is at 84. I have a flashlight. I've broken into the work office here. I'm poking around. I shine it at the wrong area. I move on. I go and I do my stuff. And unbeknownst to the robber, the buzzer comes on, and as the campaign illustrated, we saw the value. We missed it, but it popped up to a higher value than 2,000, and the buzzer comes on. And so I'm going to come back over here and I'm going to push the disarm button, because I'm sure nobody wants to listen to that for very long. And we will see that we've disarmed the buzzer and it goes off. So let's just give it a second here. And
Matt, I think if you refresh your page, will you also see the update from the light value?
Well, it actually did update. We just missed it because once the flashlight hit it, it went high above 2,000. Then it came back right away.
Oh,
and so
okay, understood.
The page is actually refreshing right here every 2 seconds. So, we'll see the temperature climb slower than the light. The light's almost instantaneous.
Certainly, yeah.
Needless to say, the buzzer, the IoT campaign fired. I didn't have to change any code. I didn't have to do anything on the emaPlay. It was all handled by the Canopy dashboard. And so that's a very powerful tool for any business to not have to go out physically to the device to make decisions like that.
Certainly.
Just as a sanity check, we'll come over here. We will disable this campaign. So we'll suspend it, just like that. And then we'll go back. And we'll watch the values a little slower this time. We'll see if I can do it a little slower. So again, I'm going to grab my flashlight. 1 second here. Let's hit it. Give it time to report it. Obviously, there's a little bit of a delay just because of the way the message is created and sent up. And so let's see if it picks it up this time.
Yeah, definitely.
There, it jumped up. It should jump right back down in a second here once it picks. There it goes. Once it picks up.
There it goes. Yeah.
And so we've demonstrated the security application, and so let's go back to the IoT campaigns, and we'll demonstrate an over temp or a high temp warning. And this is an application that can be useful just about anywhere. If you've got a piece of equipment in a warehouse or somewhere where temperature is critical, and you want to be notified or warned about that, we can set this up this way. Again, don't have to change anything on the device. We'll come into the IoT campaign and go over a quick overview. Let me shrink this down for just a second. Similarly, we're reading sensors, we're loading the data, we're reading the environment temp JSON value. We're going to call that variable temp. Over here, when the temp gets greater than 100, we're actually going to do two things. We're going to turn the LED 1 on, which is the red LED, and then we're going to send an email to my email account, and those things are going to happen at the same time. And then again, when it goes below 100, it's going to turn the LED off. And so we're going to activate this campaign. We're going to suspend the light one, which we've already done because I don't want them contending with each other. And so let's go back to the operations page. I'm going to pull up Outlook on another monitor so that we can see that the email comes through. Give me 1 second here. Okay, so if you look at the dashboard right here, you can see that the current temperature is 74.4 degrees. And let me blow this up again so we can see this a little better. Sorry, Sean, I didn't mean to cover your face there.
And we are going to take it up above, we're going to take it from 74 degrees up above 100 degrees.
That's what we're going to try and do, and we'll see how many. I don't want to burn up the board, so I got to be very careful here.
Be careful, for certainly.
So I've got the heat gun going. I'm going to let it warm up a little bit so that it hits the board and heats it up very quickly. And so we'll hold it on there for a few seconds, just like that. We'll see how high it gets. I'm hoping it gets close to what we're going after. So let's give it a second to report in. I see that it's reported in. I can see on my debug it's at 85 about, so it's not high enough. So we're going to hit it again. It's got to go to 100. It's not going to do anything.
Just don't melt it.
That's what I'm trying not to do. So this time I hit it for longer. And I can see again on my debug, it went to 98.7. So obviously I'm not very good at
Oh, there it is.
One more try.
One more.
There we go. So let's see what we get to this time. 95. I bet it's going to go higher. 103. Let's see what happens. So if you watch over here, we should see this LED come on.
Yeah, there it is.
Oh, not quite yet. Right there. Now it just came on.
Oh, yeah.
Okay. So now we're going to watch it. Watch over here, and we'll see if once the temperature goes below 100, it's going to turn that LED off. And so it's, what are we looking at, 98.5. We should see that LED go off in just a second, and there it goes. Obviously, LED is not very useful, but you could connect that to anything with digital input. You could connect it to a relay and control a fan or something to that effect, right?
Certainly, yeah.
So the other piece to this is the email that it sent. So let me pop that up. Here we go. It came in at 3:34 just a few seconds ago, and there we go. Device warning, high temperature. And so we basically created two actions from that one input without changing any code, without doing any tough development work.
That's awesome.
Yep, basically using the power of the IoT campaigns over here. And so that's our demonstration for today. Now I'll pass it back to Steve to close it out.
Well, thank you very, very much, Matt. I really, really appreciate you walking us through that demonstration. Everyone, thank you very, very much for joining us today. It's our sincere hope that you walk away with some ideas that you can take back to your own IoT projects, back in your own companies. If you want more information about Canopy or Banyan Hills Technologies, feel free to come to our website, banyanhills.com, and get some more information there. You can, of course, follow us on LinkedIn or Twitter or Facebook. Sean, where can people find out more information about OptConnect?
Sure, you can definitely go to our website, OptConnect.com. You can do OptConnect.com/Emma, and to get additional information, you can send an email to sales@OptConnect.com. Also follow us on any of the social media platforms, LinkedIn, Twitter, Facebook, Instagram, away you can go. So definitely a good way to follow the activities of OptConnect.
Wonderful. Well, thank you all again, everyone, for joining us. Have a great day.